explaining how some of the tools that we at Parity use and develop, and some that are community maintained, work, and how to use them to facilitate building on Polkadot. Second, I will share my screen so you can see. Okay. So, as I was saying, I work at Parity. I've been with Parity for almost a year, working specifically in the first in the integration teams, now in the front department. So I specialize in helping teams start building and start working with Polkadot, with Kusama, and start using the frame and substrate to develop their own chains. Today, I will be talking to you about five, more like four specific tools, and a special and honorable mention. So the four tools that we at Parity maintain are called TX Wrapper, Substrate API Sidecar, Asset Transfer API, and SubXT. And the honorable mention goes to Polkadot API. You will see why when we get there. So basically, the goal of these tools is to facilitate building in Polkadot, and a large portion of building and working with Polkadot is interacting with the chain. So you have your own application, you have your own dApp, you have your service that wants to interact with the chain, and most of the time, running the RPC calls directly can be kind of messy, or interacting with the chain, let's say with an XCM call, can be a little convoluted, especially if this is your first approach to Polkadot, this is your first approach to how XCM works, what's the difference between a relay chain, between a parachain, between a collator. So our goal in the front department is to ease that path, to facilitate the teams that want to build and work with Polkadot. So we provide these tools that are maintained by us, such as TX Wrapper, Sidecar, Asset Transfer API, SOXT, and we keep constant track of the evolution of the runtime. We update them with new calls, with new functionalities. We make sure to take notice of the issues that come up, and we attend to those. We keep track of feature requests. We keep track closely of what the community wishes or requires at specific points, and we make updates accordingly. And that's mostly our job for these tools. Let's start with TX Wrapper. TX Wrapper is a Polkadot.js based suite of packages to provide chain builders with tools to quickly create, test, and maintain a library of helper functions for offline transactions generation with their chain. What does this mean? TX Wrapper provides a simplified and a reduced, in some of their packages, a set of functions that facilitate generating offline transactions. TX Wrapper envelops packages oriented towards the Polkadot relay chain and system chains, others towards providing support for registry creation, and even some providing the essentials for creating a chain-specific TX Wrapper library. So TX Wrapper is a package of packages, you could call it. So it's a bundle of different libraries that include TX Wrapper Core, TX Wrapper Dev, TX Wrapper Registry, and TX Wrapper Polkadot, and TX Wrapper Substrate. Each of these packages exposes helper functions specific or oriented toward that area itself. So TX Wrapper Polkadot exposes calls additionally to what TX-Wrapper Substrate and TX-Wrapper Core provides, exposes calls specific to the Polkadot relay chain, Kusama relay chain, and the system chains. So you have calls such as some XCM calls, and then you have below that you have TX-Wrapper Substrate. The TX-Wrapper Substrate exposes calls that are quite common for the general chains. And these calls, let's say a balances transfer, an assets transfer, foreign assets transfer. And then you have TX-Wrapper Core itself, the package that gives you the tools to build your specific TX-Wrapper package. So, for example, Akala uses that, and there is a package published by Akala that's called TX-Wrapper Akala that exposes functions that are specific to Akala, that they find are helpful and that are built according to specifications from Akala. Nonetheless, as I mentioned earlier, you can use TX-Wrapper Core to develop specifically what you want to use. So, moving on. Well, there you have the link for the repo, and the owner is Parity, as I mentioned earlier. If you have any questions, or if at the time of using that you face any issues or any errors, you are welcome to raise an issue in the repo or to ask a question in substrate.stackexchange. So TX-Wrapper, here we have a specific example to showcase how the general structure of TX-Wrapper Core is shaped like. For example, here we have a transfer keep alive. This is a method that is exposed by TX-Wrapper Substrate, and you can see three specific arguments, or three specific groups of arguments. Each of these fields correspond to a specific area of the call, and it's required for the package to be able to build the transaction correctly. So in a shape that can be recognized and is recognized as valid for the blockchain. You can see in the first part, you can see two fields, value and destiny. These fields are grouped into the args, value of the overall call, of the TX-Wrapper call. So you will see that these fields, depending on the call, vary. So these are not static. They change depending on the requirements of the call. They are specific for the method that we are trying to reach. On the other side, you have base transaction info. That is that large second argument. Here, that field contains information that is common for all transactions. So the fields in base transaction info, the data in base transaction info, is required for all the calls. Any transaction that you wish to make will have to address these specific fields, whether you use them or not. Some of them are optional. For example, asset ID is optional, tip is optional, but they must be present. If they are not present, they default to a specific value. For example, address refers to the address that we are sending the transaction from. Asset ID, it refers to when in Polkadot, there is this concept of sufficient and non-sufficient assets. Up until a couple of weeks ago, you could pay the fees for the transaction in either the native token, let's say DOT or Kusama, or an asset that is recognized by the chain as sufficient. which are these specifically USDT and USDC. We're not going to go into what it means that an asset is sufficient or not. Only keep in mind that a sufficient asset allows you to pay for the fees of the transaction with that asset instead of that. Now, with the last runtime upgrade that incorporated the asset conversion palette in Polkadot and Kusama, we also have the ability of paying the fees with an asset that is backed by a liquidity pool. Again, we're not going to go into much depth about what liquidity pools are or what the asset conversion palette is. Just keep in mind that now we basically can pay the fees in almost any asset that is available in the asset hub. There are some nuances to this. Specifically, it has to have a liquidity pool backing it against the native token, but you can see the amount of flexibility that this grants us. The block hash is the block hash of the latest block. The block number, same, but specifically converted to a block number. The error period is the amount of blocks during which this transaction will be valid. It defaults to 64 blocks. The genesis hash is the genesis hash of the chain itself. The field metadata RPC is the metadata of the chain, the latest metadata of the chain, this is very important, formatted as a hex string. So the nonce is the nonce of the account. The spec version is the spec version of the chain. The tip is there for if we want to tip the validator in order to fast track our inclusion in a block. And transaction version is the transaction version that is being used in the chain. Let's see if there are any questions. No, okay. So the idea is that these fields are provided at the moment of building the transaction, but they are retrieved from an offline source. So what does that mean? We all know that building transactions offline is the preferable way. So if you're moving a large amount of tokens, you may be target for some bad actors that want to steal those tokens and want to impersonate you and may want to steal your data. So you generate the transaction, you sign it all offline, and then you submit it. To be coherent with this, you also need to keep this information, such as the block number, the metadata, the spec version, in an offline environment. So you retrieve it, however you retrieve it from your local node, from some oracle you have going around, you store it, and then at the time of transaction construction, you check that those are the latest values and you input them in order to build the transaction. But it's the correct and the preferred way is that you retrieve those values from an offline source, so you can keep the entire process offline. And finally, we have this field called options with meta. This field contains runtime specific options for encoding and decoding the transactions. So this means that these are not part of the transaction itself, but they are necessary to be able to encode this transaction into scale. That is the language that the runtime understands. So you again have the metadata. You have an optional value called as calls only arg. Then you have another one called a specified calls only B14. Another one called sign extensions, user extensions, registry, and is immortal era. So for sign extension and user extensions, you are able to inject a specific sign extension that maybe you didn't have present at the time of retrieving the initial information. Or you want to add some custom sign extensions because maybe TX wrapper doesn't recognize those, and you know that they are there, and you want to, they say, go around that hurdle, and you can inject them at that moment. Right now, I'm going to show you. Let's see how we can do it. I'm going to show you a little bit, a small demo that uses TX wrapper. For this, we already have running a zombie net with a relay chain and with a Rococo relay chain, and the Rococo asset hub and the Rococo core time chain, which is since the last runtime upgrade is required. Give a second. Let's see how I can show you this. Second, show you one. Okay. All right. Let me open. Here we see the information from a specific zombie net that we're using. Wait a second. Okay. All right. Let's cd into the corresponding. Let's run yarn. Sorry. Let's give it a little while so that it can work. Let's see if we can. Yes. Live television, everybody. Okay. So we have some going on, facing a few issues here. I need you to be patient with me. So what we're trying to mimic here will be a simulated transaction that is being sent to the relay chain. And packages samples. Okay, let's see. Can work with same. Okay, yeah, I'll show you. What is this? Okay. Not everything's going according to plan. we'll have to, we'll just move on. So that was a mess. Okay, sorry about that. There are some unexpected technical difficulties with that. We will have to move on to a different task. Uh, a note that is worth mentioning now is that all these examples, all the repos for the tools that I'm showing you today, they all have their specific examples. So TX Wrapper has a really complete suite of examples. As Transfer API also has one. SubXT has some very interesting guides, so you can check those out. If hopefully this will be the only one that fails today, but yeah, who knows? Moving on, we will start with we'll go on with Substrate API Sidecar. So, Substrate API Sidecar is a REST service that makes it easy to interact with blockchain nodes built using Substrate framework. It allows abstracting some complex RPC calls into simple REST calls, enabling a simple node interaction through its available endpoints. It's primarily thought to be run alongside a local collator, though it can be configured to connect to a remote RPC node. The idea behind Sidecar is for it to run attached to a local node. So let's say you're running your own validator, or you're running an archive node, or an archive collator, and you want a fast and easy way to retrieve information from the chain. So what do? You use Sidecar. Sidecar, the one of the main benefits that Sidecar provides is that it's stateless. So it adds practically no overhead to to the requirements of the node itself. So we all know that running a node can be pretty taxing, requirement wise. So it's always good to know that having a tool like Sidecar that doesn't take up any space, it only needs a few gigs of RAM to work. It's available and you can use it. This So Sidecar works as a series of endpoints that you can make a request to, like get or post request. You can, for Sidecar, you can specify the URL that you are connecting to, because you can either connect to a local node, or you can also be trying to connect to a public RPC node or some remote RPC. The thing is, while connecting to remote RPCs or public RPCs, the main issue is that there's usually a remote RPC adds latency, sometimes little, sometimes more, but it adds latency. And the public RPC is often rate limited. So if you want to get some information that it's uh, time pressing, you should always try to use a local node. There are a couple of public nodes that are available, are thought mainly for testing, that are currently maintained by Parity. These are rate limited, and these are mostly thought of a way to, for the a new user or someone who is interested in using Sidecar, can see how the endpoints behave, what the endpoints return, and with that get a rough idea of how it works and what to expect from it. You can also refer to the documentation. It's also very complete. There is a really nice page in which you can make test queries to see how the response is shaped like. So I strongly suggest that you give it a go. It's all available in the sidecar repo. Check it out. It's really interesting. So here's a list of frequently used endpoints. As I mentioned earlier, there is a quite extensive array of endpoints from which you can query. These are the most frequently used. Of course, from the endpoint onwards, there are more specific calls that can be made. You can specify certain parameters, but these endpoints are roughly grouped into these ones. For example, accounts. Accounts is a group of endpoints that allows access to relevant account information. What does this mean? It basically means that you can retrieve information regarding an account balance, an account status, if it has locked tokens, if it has frozen tokens, a lot of information. You can see the specifics again in the repo. The blocks endpoint is a group of endpoints that allow retrieval of block information, such as their header or extrinsics. This is quite widely used. So let's say you want to keep track of the evolution of a transaction or you want to keep track of the evolution of an XCM call to see how it's going, to see when it's finalized, to see if it gets rejected, why. You can call the blocks endpoint and set it up to make repeated calls, and you can comb through the events of that endpoint, of the answer of that endpoint, and you can see if within that block it's the event that you're interested in. Or you can also just check the extrinsics of that block, or you can just retrieve the header to see what's the block number, what's the latest block hash, and maybe with that information you could even go and use TXWrapper and build your own offline transaction. The node is a group of endpoints that allow retrieval of information related to the node it's currently connected to, such as the client version or networking data. So this is mostly a couple of endpoints. It provides information on the node itself that you're connected to. It's not that widely used. It has some specific use cases, but it doesn't provide that much information either. It's just that specific some networking data if you want to connect to it, is if you want to see which client it's running to make sure that you're connected to a node that is up to date. There are several nodes that are running really old versions of Polkadot that can cause a lot of errors because there are a lot of new functionalities and a lot of new host functions that won't be recognized by that node. So most transactions will fail. So it's always nice to see which client version you are running. The palettes is a group of endpoints that allow retrieval of information relative to specific palettes, including the runtime, such as the list of events, constant, or storage items. This endpoint basically what does is gives you information regarding specific palettes. So you know that you're looking for you want to see which are the events related to the assets palette. You want to see which are the constants, what are the storage queries that you can do. You can always specify, call the palettes endpoint, and with that you can just make check what the palette ID is, and with the palette ID you can query specifically the data from that palette. You also have the runtime endpoint, that is a group of endpoints that allow retrieval of information related to runtime, such as the metadata of the spec version. in, again, two values that we require in TX wrapper. The metadata returns as a scale encoded hex string, and the spec version just as a string. Give me a second. Then you have the transaction endpoint. This one's small, but it's interesting. So these are a group of endpoints that allow both submitting transactions as well as retrieving information for their construction. So far, the only thing that we've seen Sidecar do is to get information from the chain and bring it back to us. So we could almost see it like a courier, a one-way courier. But that's not all it does. Within the transaction endpoint, you have a specific endpoint that is a post request that allows you to submit a signed extrinsic. So, a signed transaction. So you, again, going back to TX wrapper, you build your transaction, you use Sidecar to retrieve information about the status of the chain. You use that information to build your transaction, and offline, you sign it offline, and now you want to submit it. You can also use Sidecar. You can feed Sidecar that transaction, that signed transaction, for this endpoint, and it will submit it to the chain as if we were submitting it through an Polkadot apps submit extrinsic, or as if we were running a script that uses Polkadot API or Polkadot JS API to submit the extrinsic. So that one's quite useful. And another one that is really useful, maybe not for the common folk, but if you are running a nominator, or if you are running a validator, or if you overall are interested in how the staking evolves, you can use the staking endpoint. The staking endpoint is a group of endpoints that allow retrieval of staking information, such as the payouts for a validator for a specific era. This is really, really big and really interesting, because most of the calls to see how the payouts were distributed changed throughout the ages. So since the early eras of Kusama, to give you an example, since the early eras of Kusama, up until this point, there have been a myriad of changes regarding the storage queries, the calls, the events that you need to look up for to see if a reward has been paid, how the rewards were assigned to whom. So, and this taking endpoint does all that work for you. We in Parity made the effort to go through all those very ancient eras, see how they behaved, see how they evolved, and based on that, to set up Sidecar to recognize and to calculate correctly the payouts, to the points, whether it was claimed or not. So it's really useful. If you try to do that by hand or brute forcing it, it will be a huge headache. So there another reason to using Sidecar. Now I will show you those public endpoints that I talked to you about a few minutes ago, so you can see how they work. Okay. All right. Sure. Let's share another one. Okay, so let me zoom in a little bit. All right, this is the endpoint that I was talking to you about. It's Polkadot public sidecar .paritychains.parity.io. What this does is this is an instance of sidecar that it's publicly maintained by Parity. It's rate limited, but it can work. It works as a way to showcase how sidecar works. This is the list of endpoints that you have available, the path to each of them, where is a get or a post. As you can see here, you have the accounts in which you can input an address and retrieve a balance info. Let's see, and one blocks head returns you the latest block. Blocks number returns you the block that you're specifying. Blocks header returns you the header of the latest block. Blocks block ID extrinsic index returns you a specific extrinsic for that block. You have a bunch of experimental endpoints. You have this one that is the one that I was talking about earlier, node network, that it returns the network information for the node you're connected to. So the IP, the amount of peers, and so on. You can also get the transaction pool for that node. You can get the version for that node to see if it's up to date, to see if it will understand or will be able to encode or handle correctly your transactions. Then you have all the pallets endpoints, and here you have a few that these paras endpoints that are oriented towards parachains, working with parachains. With the introduction of core time and the upcoming or the planned or envisioned maybe introduction of core jam, this will be probably deprecated, or at least I don't know if it deprecated, but most of them won't work. Yeah, so don't get too familiar with those. All of experimentals. Well, you can get here. You can get the metadata, runtime metadata. Let's see. Let's run that one. That one's fun. So you can see how it behaves. Just metadata. As I said, this is a remote node. This is rate limited, so the information takes a little bit longer to retrieve. So here you go. Here you have the metadata as a JSON, and the magic number, the metadata, a lot of fun and clear types, the which palettes are present, which extrinsic events, all of that, and you can use that to build your own transaction or to update your metadata. Well, the world is your oyster with Sidecar. Going back, let's let's see which. And these are the ones that I was talking to you about, transactions. Here you have a transaction dry run to see if your transaction will run correctly or not without specifically submitting that transaction. You have this transaction fee estimate in order to estimate how much you will have to pay for that transaction. And you have the transaction itself that is a post request so that you can submit the transaction itself as a hex encoded string. No. That's mostly about it. It's always, as I said earlier, and it's always to refresh this, the recommended way to use Sidecar is to attach it to your own node. your own local node. If you're using it scarcely, you can always use Parity's public endpoints, or you can use just attach it to a public RPC endpoint. But as I mentioned earlier, that comes with more latency and often with a limit to the amount of requests you can make per certain amount of time. So it's always nice to have your own node running. Going back to the display itself, so what is called sidecar. Oh, hey, we have a couple of questions. Uh, Side question, but why is it called sidecar? Well, it's called sidecar mainly because you say you can all you know the sidecars for the motorbikes. So you have a motorbike that has two wheels, a seat for one or two people, and you always had those old, now are coming back, sidecars that are those little egg-shaped things with the extra wheel that allow you to have a passenger. If you remember, there was a cartoon called the crazy cars, los autos locos. I don't know what specifically in English how it was, and you have always this evil dude with the big hat and the large mustache, and he was always joined by a dog, a grumpy dog, an evil dog. And sometimes they flew by plane, and sometimes they used a motorbike with the sidecar. So the idea is that sidecar goes attached to the motorbike. That would be your node in this case, or some sort of node. Yeah, I think that's the main reason behind sidecar. So I want to see if this I can get on-chain identity data and the event for a particular address. What's the best way to get it? Oof, that's a tough one because for events you cannot query them by address. You must specifically check each block with that and check the event itself. Sometimes the event discloses information related to the address that caused the event. Let's say staking rewarded. That tells you how much was rewarded and to which address and for what era. I think no, I don't know. So in that case, you will need to query the blocks that you're interested in. If it's a recent, let's say it's a recent transaction or it's a recent success, and you want to see when that goes through, or if you are waiting for a payout and you want to see when that staking payout happens or when that era changes, you have to subscribe to blocks. I will show you how to do that with SubXT later on. With Sidecar, you will have to query the blocks that you're interested in and use that information to come through the events of that block. And within each event, you will have to see if the event you're looking for is contained. And within those events, you have to filter by the account. So it's messy. It's not as straightforward as it could be. With Sidecar, I don't think Sidecar would be the best tool to do that. It would be better to just maybe write a small script, a small bot to keep track of that. All right. I hope that answered the question. Moving on. Going back to the presentation. So this was the demo that I talked to you, that I showed you just a few minutes ago. And now we get to the one of the jewels of the crown. This one is a very big tool. It's really cool. It's really interesting how it's designed, how it works. We all know, or I assume if you're looking into Polkadot, you know what XCM calls are, what XCM, the cross-chain messaging protocol is, and what cross-chain messages are. And we all know that it's not the most, how do you say, straightforward way to make transactions. So it can be a bit of a headache to write some cross-chain transfer, or if you want to write, let's say, you want to send the tokens from the relay chain to any system chains, or vice versa. Writing the XCM call can be a little bit convoluted. So it's not very user friendly. So what we set out to do is to see how we can make it easier. Mainly that's our goal here. So it's freezing in Buenos Aires, so if I don't read something word, I'm gonna get sick. Okay, resuming. We set out to see how we could make using XCM calls and using the asset hub and making cross-chain transfers easy. And we came up with this, the asset transfer API. Basically, the asset transfer API is a library that's focused on simplifying the construction of asset transfers for substrate-based chains that involve system parachains, like the asset hub, or Polkadot and Kusama. Now it also supports some cross-chain transactions from parachain to parachain with some nuances and with some small tinkering, nothing too complex related to building an XCM call by hand. But it's there. Asset Transfer API exposes a reduced set of methods which facilitates users to send transfers to other parachains or locally. There you have the repo address, the owner is Parity. Basically, Asset Transfer API, what does is tells you, okay, you want to make a cross-chain transfer, asset transfer. You have to input this data, which asset you want to send, to whom, which is the, if you want to have it work as a payload, as a call, as a submittable. And ATA does all the heavy lifting for you. So you just feed it some information, it does some magic behind the scenes, and it returns, depending on what you need, a submittable extrinsic, the call itself, or a signing payload. I will show you in a bit some examples of that. So this is the general structure for the Asset Transfer API. This is overall how you construct. Oh, this is really annoying. Okay. So this is overall how you construct a transfer with Asset Transfer API. First, you need to retrieve the API, the spec name, and the safe XCM version. The safe XCM version is the version that the chain recognizes as admissible. You just provide this method, construct API promise, with an endpoint in order to retrieve that information from and to build that API. Then you create a new instance of the Asset Transfer API with new Asset Transfer API, providing the API, the spec name, and the safe XCM version. You could also build those three things without construct API promise. It takes a little bit longer, more steps. And then finally, you can build the transaction itself. So the transaction, you can see that it returns a TX result of type T. That type T can be either a call, a payload, or a submittable. you need to provide the to the create transfer transaction. You need to provide the destination chain ID, so the ID 1000 for the asset hub, 1005 for the core time chain, 2000 for some para chain, the destination address, so to whom you are sending the funds for, to the asset IDs. You can see that it says asset IDs in plural. This means that you can provide it with an array of several asset IDs if you wish to transfer several different assets in one go. Pretty cool. And the amounts. These amounts, again, it's an array of amounts that correlate to the array of asset IDs. And then this final field that is called transfer ops, also depending on the type of call you want to make, or a call, a payload, or a submittal. Transfer ops is basically the some optional arguments that you can pass to the create transfer transaction in order to customize or to define some particular elements of the transfer transaction. Some of the options are format, in which you define whether you are building a call, a payload, or a submittable. This, if you're building a payload, you need to add sender's address. Well, it's just written down below, but okay. Pays with fee origin, there's the asset ID to pay the fees on the current system chain, which means, as in TX wrapper earlier, you can specify either a sufficient asset or an asset that is backed by a liquidity pool to pay the fees on the system chain. Pays with fee desk is if you wish to use a specific asset to pay the fees in the destination chain. Again, it has to be sufficient, or it has to be backed by a liquidity pool. As I mentioned earlier by mistake, the sender's address, that is the address that will, from which the transaction will be sent from. It's required when you're building a payload. For the other types of call, you don't have to provide it. For a payload, you do. Weight limit, if you want to if you want to set the amount of weight you're willing to pay for. This is, as you may or may not know already, weight in Polkadot and Kusama uses already weight B2, so it's formed by both ref time and proof size. So ref time is the amount of computational time, and proof size is the size of the proof that is provided. So those two you need to specify when you're specifying the weight limit. XCM version, if you want to set a specific XCM version for the method construction, if you don't specify that, it defaults to a safe XCM version. Keep alive, where the transfer is a transfer keep alive. So if you're making a token transfer, let's say you're sending DOT from an account in the Polkadot relay chain to the Polkadot asset hub, and you want to say, okay, send all my dots. I don't want to, and just rip the account. You set it to keep alive to false. So it converts that call into a transfer allow depth. So it allows to send all the tokens without checking for the existential deposit. And transfer liquid token is something that has been added quite recently, and it's in order to work with the liquidity pools. So without going to much detail, a liquidity pool is uh, is is formed by two assets. In this case, the native asset and a custom asset, could be a foreign asset, whatever. And that token grants you, once you add liquidity to that pool, it grants you a token, liquidity token, that represents your holdings on that pool. So as any token, it's in this case it's living in the pool assets instance of the asset palette, it can be transferred as spent. So if you want to make a liquid token transfer, you have to set this to true. Let's see if there are any questions. Nothing yet. Okay. And here we will see how this asset transfer API works. So if I can just straight up show my screen. Okay. Let's see. As I mentioned earlier, in the, I know the size is too small, so I'll make it bigger. Let's just close this. As mentioned earlier, in the repos, such as this one, you have a lot of examples. Let's say we want to send our tokens from the relay chain to the system chain. So you want to say tokens from Western to the asset hub Western. You can straight up, you specify the type of call you want to make. In this case, you want to make a call. You specify the destination chain. In this case, since we aim to send it from the relay chain to the asset hub is always 1000. You specify the sender's address, the destination address. You specify the token that you want to send. This is interesting because in the token array, you can either provide a number or a ticker. So you can say, okay, I want to send a dot from the Polkadot relay chain to system chain. You can either specify the token as 0, which is the ID of the native token, or you can straight up specify it as dot, and it will recognize both cases. So that's pretty cool. Then you specify the ID, the amount you want to send. Here we specify the format as a call, and the XM versions we set it as to true. And let's see another one. Here we have another one that's built as a mutable extrinsic that is designed to send tokens from the relay chain to an asset hub, in this case Kusama asset hub. Again, you specify the destination ID, the relay chain ID, the destination address, the token, the amount. In this case, you set it as submittable. When a token is submittable, or when you create a submittable transaction, you can then take that submittable and either print it as a hex string if you want to sign it and submit it offline or somewhere else, or maybe you want to sign it offline and then submit it, or you can straight up use that same call info and sign it there and then. So you can call info transaction, sign and send, and you can just straight up submit that extrinsic. Let's see if okay, let's see if we can have another example working. account. Fix this one. Okay. Let's try this. Let's go to the asset transfer API. Here. Let's build the example and let's say. Okay, yes, this won't work. I don't know what's going on with my TypeScript today. But we can also just straight up use the examples that present there. Where are we? We can also use this one. Let's say 9944. We can use 9900, which is my local node. Submittable. Okay, I'm Rococo, so we want to transfer rock. That's all good. Yes. Yeah. Yeah. Build. Awesome. What's the call for this one? Okay. This. And we can just now we are in API samples build, and this one is middle build. Okay. Okay. Yes, and if we are lucky, this will work, and we should get okay. There is it. So if we go now, this was submitted. So if we go now to, I don't know if you will be able to see it. Let's do the whole window. If we go to, here we go. This is the asset hub. This is the relay chain, the Rococo relay chain. We can see here the XCM message in which sends, let's do this. No, here we'll see it better. Here, it's a lot of information, so maybe you can't see it all. You can see the call that was made, destination, the XCM version location set as a v2, as we wanted it to be. We can tell that this one is our call because the safe XCM version for Rococo is v3. So we can see the parent 0, the destination is parent 0, location parachain 1000. The beneficiary is the S1, the account ID that we set. And here is the amount. Agreed, fungible, just the amount. And here in the other side, you can see, where is it? Here, notifier requested. This is when our call requests the safe XCM version. When we wanted to generate the call. And this is the one. See if this is the one. Or it's one. Okay, I'm not seeing where specifically the transaction went, but if you go to accounts, you should be able to see. Yeah, this is in million of rocks. So yeah, it would be kind of difficult to see it. Oh well, and you can also the interesting part of asset transfer API is that you can just decode the message you sent. So as you see here, we have the transaction itself that if we copy and try to decode it, okay, this was a submittal. We try to run the same. We can just do console info.tx. We should be able to see. Give me a second. Of course, to hex. And now we can see the transaction. And this very same transaction, if we sign it, we can use it to, we can send it as an XCM call. Going back to presentation. Let's close this. I hope that was interesting. It's way easier to use the asset transfer API than it is to build an XCM call by hand. So you can also integrate that into your own application, into your own app. Just import the package and you have all the methods available. You can use it to streamline, if you're on an exchange, you can use it to streamline tokens transfers. If you're just using or building some sort of dApp, you can use it in order to manage funds in, let's say, in the asset hub if you're on a parachain. Or you can simply use it to make some token transfers if you're not, if you have your own script and you want to make an SCM call, if you want to make some testing. It's pretty useful for testing because you can just import it in your script, build the XM call, and just send it. You want to see if your parachain, if your the barriers, the XM barriers of the parachains are correctly built, correctly coded. If you want to see if your XM version is correctly set, so that you want to make sure that it will work with the other parachains or it will work with the relay chain after you make some changes, or if you're getting ready to deploy it, it's also useful. Moving on, SubXT. Okay, SubXT from these ones, is the only one that uses Rust. I mean, Sidecar uses Rust to calculate the payouts because Sidecar, because the staking payouts are calculated in Rust, and in order to maintain the granularity that requires the payout calculation, Sidecar has a package that includes a Rust calc script. But SubST is entirely built in Rust. SubXT is a Rust library for interacting with substrate-based nodes. It has a focus on submitting extrinsics, hence the name. However, it's also capable of reading blocks, storage, events, and constants from a node. So SubXT at the beginning was focused on building and submitting extrinsics. That gave it the name, and that has changed from the beginning and up until now. A lot of things it has evolved and now provides a quite wide array of functions. So these are some of the features provided by SubXT. It has a static type interface, flexible encoding, decoding, offline ready, so you can use it. Let's say offline ready means that you can download the metadata and you can use that metadata to build an offline transaction with some other information that you want to use, and you can generate the transaction and you can sign it and you can do all that in an offline environment. So in this case, there is no need to, as in TX wrapper, there's no need to retrieve information from the chain just in time to make the transaction. Can use data provided at runtime. So this also grants it a huge amount of flexibility. It's related to flexible encoding and decoding. Since SubXT takes the information, encoding and decoding information straight from the metadata, it's really flexible and it's really easy to adapt it to different chains. So it's not like SubXT is designed to work with Polkadot and Kusama and that's it. If you want to use it with different chains, maybe a parachain, or maybe you want to use it with a system chain, or you want to use it with your own local custom chain, you can do it. It's okay. Can be compiled to WASM. This is really cool because you can use SubXT, compile it to WASM, and have it run in a browser. So this means that you can use SubXT in a dApp that is running in the browser. There's no need to have it running as a separate entity. You can just bundle it together and have it running straight in the browser. And the last one is that it's palette oriented. So since it's palette oriented, it's really easy to find the events that you want to, the extrinsics that you want to use, the types that you want to use. It's really straightforward. It's if you have used Rust before, you will have no problem in finding and figuring out how to import the different types that you need. A strong note, so a strong uh, footnote that needs to be made about SubXT is that it's not expected to work with blocks produced prior to the runtime update that introduces B14 metadata. There is a separate project that's called DSAP that is meant to work to handle these historic blocks, historic substrate blocks. DSAP means decoding historic substrate blocks. But right now, SubXT is not expected to work with all blocks, like really all blocks, so previous to metadata B14, and most of the times it won't work. It could work for those streaks of luck, but it's not expected to work, and it's not one of the things that SubXT will provide. Um, Yay! Now we have a small demo. This one will work because this is Rust. Rust always works. A second, let's add another one. So, okay, I'll show you the screen so you can see it. We need to use this one, just like this. Let's make it a little bit bigger. Just do this. Okay, so here we have basically some of the how a regular subXT script will work. First of all, well, this signer and address are mainly for a point further in time where we want to sign and submit an extrinsic. So these are just dev accounts. It's the Alice and Bob we all know and love. The URI is the URL of the endpoint we want to connect to. So in this case, it's my local node. With that URI, we create an online client. You can also create an offline client. But now, right now, we just want to see how it works. Here, we retrieve the events, the latest events that are going on in the blockchain, and we log them to see what's going on. We can see if this is dynamically decoding, and this is, we can see if we can statically decode them. Sometimes this static decoding may fail, usually it doesn't. Then we set Bob as our destination account because we want to make a transfer. We define the balance transfer. For this, we call Rococo, which is the mod that handles the metadata, is how we named it. So we use Rococo balances, Rococo transaction balances. As I mentioned earlier, this is heavily focused on pallets. Because Rococo transaction balances, we are making a transfer out of depth, the destination, and this amount of tokens. And then we simply just create the transaction, API transaction, sign and submit, then watch. This one is if we want to subscribe to the events that happen after the transaction. So it's this similar to what we use in Polkadot.js, Polkadot API, when we want to subscribe to the events to see when a transaction was finalized. We wait for final success and then we run. Now we can. What is this? Okay. Let's do wasn't workshop. We change to XT. And here, I don't know if we already have the metadata. Download it. Looks like no. All right, so what we can do is copy this link. So it's the metadata. What this does, this specifically is the subXT CLI. So SubXT has two sides. You have the SubXT CLI, which is a CLI tool to handle. It's the CLI version of SubXT. In this specific portion, in this specific case, we're going to use it to retrieve the metadata from our local node. If you see, we can format it as bytes and then place them in a folder called metadata as .scale. Let's run this. And that was fast. Let's see if this worked. And here we have it. Can also use it, set it as JSON. And we can see that we have the metadata, but formatted as a JSON file. So these two things are the same. The only difference is that one is the only difference is that one is formatted as a JSON, so you can just read it. This is mostly useful if you want to have some idea of where you need to call or where some specific types or calls are stored. And the other one is the one that uses SubXT. So now we can, I don't know if this was already run. We run a cargo build. I knew there was something missing. Wait a little bit. Shouldn't be long. So what SubXT does is takes that metadata, and with that metadata, it builds the correct transaction. So if we have up-to-date metadata, there should be no reason why the transaction that's built with SubXT fails. So warning, nothing of concern. Done. Okay, and now let's clear the screen. Let's leave it cluttered. We can do cargo run. Okay. There was something of concern. This is not used anymore. Oh, come on. Yeah. So no longer using this one. Let's see. No questions. Okay. Let's get back to this. If you have any questions, or if at the time of trying out these tools you face some kind of issue or you have some kind of problem, feel free to raise an issue in the tools repo. You can also, if the question is more like, how can I do this, instead of I'm trying to do this and it's crashing catastrophically, you can always go to substrate.stackexchange, post the question there, or see if the question is already present there. And if it's not, you can post it there and we will answer it, or someone will answer it. There's quite a big community there. It's also part of our job to take care of those questions. So feel free to use us. We're here to specifically deal with TCP. Oh my god. A lot of days for things to go south. And no, it had to be today. Let's copy this. Oh, don't tell me this because I set it as a WSS instead of WS. Silly small mistake. And then you can see all the events. Dynamic event details. Yeah, it's ugly. It's shaped ugly since it's returning bytes. The relay pattern. It's also, you can see it here. Let's see if we can make it a little bit bigger. Looks like we can. Okay. If you see here, we have the event for our transfer. We have the dispatch info, the weight, the rest time, and the proof size, where it paid fees or not. This small message that says that our balance transfer was successful. And here we have all the extrinsics that were present, all the events that were present in the latest block. As you can see, it's all presented as bytes. You can always decode it, or you can use that. Depends on specifically what you want to do with that information. And that overall concludes what are part of SubXT. As you can see, SubXT not only works to submit extrinsic, it also has quite a few more uses available. And there are many more on the way. All right, now for the honorable mention, Polkadot API. Polkadot API is a suite of libraries, each designed to be composable, modular, and fundamentally aligned with a light client-first approach. Polkadot API aims to be the main alternative to Polkadot.js for teams that want to develop their projects within the Polkadot ecosystem with a minimal library-agnostic interface. There you have the repo, and the owner, in this case, is not Parity, is Jose Pot. He used to work at Parity. Polkadot API was born at Parity. Joseph has since left Parity and is working on Polkadot API with treasury funding. Joseph is really has built a really great team, and it's working really hard on doing some amazing advancements with setting up Polkadot API. It's been a few weeks or months now since the first beta was released. That was a huge milestone. And the main idea behind Polkadot API is to, as we have Polkadot.js, Polkadot.js has been, you all know what Polkadot.js is. If you have done anything with Polkadot, you have at least used this page, the Polkadot.js apps. The thing with Polkadot.js is that it's been there since the very beginning. So some parts of Polkadot.js are very cluttered and very opinionated on how it should work or how certain things should be used. Also, with With time, some fixes for some breaking changes made it more convoluted. So it right now it works, and it's really great, and it's the main tool used by the Polkadot ecosystem in order to develop applications and to interact with the blockchain. But we and Parity saw that there was the need for uh, something better, or something that built on top of the foundation that was Polkadot.js, and we came out. Joseph came up with Polkadot API, and now since his departure from Parity, he's still working with that, and you can see in the Polkadot forum every quarter his updates on how the work is going. The other difference between Polkadot.js and Polkadot API is that Polkadot API is focused on working with light clients. What are light clients? Light clients are in in opposition to a normal client that takes up a lot of memory, that takes up a lot of storage. Light clients are designed to keep some very specific parts of the chain in order to streamline working with dApps. So you can have a light client that can have multiple connections, and you can just connect to your dApp to that light client in order to have it work. So you don't have to use a dApp that connects to some server, some place in the world, because that client is too heavy to be running on your own computer. Polkadot API is thinks or considers that the light clients are the future, are going to be, or are destined to be, the main way to integrate dApps with the blockchain, and they are aiming to be the number one way to integrate light clients with dApps. This also goes aligned with the composable and minimal approach that they are trying to go for. This means that if you have a light client, but the repos for your dApp are 700 megabytes, it's all the same. It's useless. So what they want to do is that you have a very modular API, so you can just import what you need when you need it, and not have that huge list of unnecessary subdependencies that are just taking us up space and not doing anything special. The main features of Polkadot API are that it's light client first. As I mentioned earlier, the approach is to work with light clients, and the rest comes later, in order to speed up and facilitate building on Polkadot. We all know that building in some other chains, it's quite easy, it's quite streamlined. Building dApps on other chains, quite it's a little bit more mature than building on Polkadot. So we want to streamline that, we want to change that, and we want to, with Polkadot API, improve the developer experience. It's also multi-chain. That means that Polkadot API can maintain connections to different chains at the same time. With this, the goal is, as we mentioned earlier, to have a wide field of usage. It's lightweight, also in line with the light client first approach. There's no value in trying to build something that it's aimed at light clients and having a light client if your dApp or the dependencies of your application take hundreds or even thousands of megabytes. And the last but not least, and definitely a really cool part of Polkadot API, is that it's compatible with Polkadot.js. As I mentioned earlier, Polkadot.js is it's it's been and still is a big cornerstone of the Polkadot ecosystem. Most, if not 99.9% of the teams that work with Polkadot use Polkadot.js in some part of their project. And it's really important that if you want to build a successful API, a successful successor to Polkadot.js, you cannot make something that will break what they already have. The goal of Polkadot API is to make the transition as seamless as possible. Right now, Polkadot.js is in keeping the lights up, keeping the lights on uh, state, which means that it's being actively maintained, but it's not planned to keep adding features since the departure of the main maintainer, Polkadot.js. It has been taken over by other developers, but the approach is just to keep it working until some other team or some other tools come to light or are mature, such as Polkadot API. And with that, we come to the end. I want to see. I'll just close this one. First of all, I want to thank you. I don't know how many people are watching. I can see it from here. It's been a really great experience, specifically, really great way to know how to prepare for the next one, and to make sure that it doesn't, not everything fails. So I don't know if I'm open for any other query. If you can reach out from the for the Discord, you can reach out and make an appointment for mentorship in Calendly. I promise you, I work better if not live. Uh, oh wait, looks like we have some questions. Oh, no, right now there isn't. So Polkadot API is in this first beta. Uh, you can either start working with Polkadot API from scratch, or if you are using Polkadot.js, just keep working with Polkadot.js until there is a more defined migration guide. There is very good documentation in the Polkadot API repo that you can use if you want to migrate from Polkadot.js to Polkadot API. It's not a migration guide itself, but it's not that difficult to know how you can replace certain stuff. It uses some of the or similar nomenclature to Polkadot.js in some things, so it's quite easy to understand. Learning to use Polkadot API, it's also quite useful, quite easy. Polkadot API, it's has been designed in a really simple way. So if you have used Polkadot.js, you can also use Polkadot API. There shouldn't be much trouble going from one to the other. So, okay, if there are any no other questions, as I was saying again, you can reach out in the Discord. You can reach out in Substrate Exchange. You can raise an issue in the repos. You can schedule a mentorship appointment with me. I am open to any kind of inquiries that you may have, anything to ease your time building in Polkadot. Thank you.